Hello students, welcome to class 11 subject mathematics chapter relations and functions. This one is 18th lecture. Today's topic is functions. So, and it's me MD Altaf Hussain, your math teacher. So, students, we will see first what is real valued function. A function which is either real number or one of its subsets as its range is called a real valued function. A function, so we already know that function from a set A to B, and it is defined by some rule f of x equal to x square and x belongs to somewhere. So students, here real valued function, a function which has either real number or one of its subsets as its range is called real valued function. So we know the first one is the domain, second one is the codomain, and whatever value we are putting in place of x and whatever we are getting here as a y, those collection is called range. So our range will be subset of R or R itself. Now real function. A function f such that a to b is called real function if its domain A is either R or subset of R and its range is either R or subset of R. So here now we are telling domain and range both will be real number set or subset of real number set. So students, now we will see example of real valued function. So students, we have taken a function from natural number to natural number. So natural number we already know is a subset of real number. So it's satisfying the first definition, and here we are getting to define it by 2x plus 1. So range also will be a natural number, and we know that natural number is a subset of real number. So our a and b both are subset of real number, so this function is called real valued function or real function. This one also will be a real function. Now we will learn some type of function. First one is identity function. Identity function, let R be the set of real numbers. Define the real valued function f such that real number to real number by f of x equal to x for each x belongs to R. So we have f of x equal to x where x belongs to real number set. Such function is called the identity function, and here the domain and range of f are real number set. The graph is a straight line as shown in this given figure which passes through the origin. So this identity function will be a straight line in the Cartesian coordinate. So students, identity function, we have to remember that f of x equal to x. Whatever value you will put here, you will get the same value, and this function is from real number set to real number set. Now next is constant function. Define the function f such that real number to real number by y equal to f of x equal to c, where x belongs to real number set, where c is a constant and each x belongs to real number. Here domain of the function f is real number itself, but its range will be only constant c. So its range is a singleton set c, but its domain is real number set. So just we have to remember, if we are putting any value in place of x from the domain, we will get in codomain only c. One value we will get. Here you will see that for 0 we have 2.5, for 2 also we have 2.3, 0 4 0. This function is actually f of x equal to 3. 4 4 also we got 3, 6 also we got 3, 8 also we got 3. Any value of the x-axis we get only 3 on the y-axis. So this function is known as constant function. So now we will see next type of function, that is called polynomial function. A function f from real number to real number is said to be polynomial function if for each x in real number set y equal to f of x a0 plus a1x plus a2x square plus dot dot an x to the power n, where n is a non-negative integer and a0, a1, a2 dot dot an, all these are real number. So students, when our function f of x is defined as polynomial a0 a1x plus dot dot an x to the power n, this way when it is defined, then it's called polynomial function. So now one example is given here, f of x equal to x cube minus x square plus 2, g of x equal to x to the power 4 plus root 2x. These are the examples of polynomial function. Now a polynomial functions, whereas the function a is defined by h of x equal to x to the power 2 by 3 plus 2x, is not a polynomial function. Why it is not a polynomial function? Because we have already told in our definition that n will be non-negative integer, but where here it is 2 by 3, which is not a non-negative integer, it is a rational number. Now example 13 we will see, one more example we will see, that define the function f from real number to real number by y equal to f of x equal to x square, x belongs to real number. So this table we have to complete and we have to find out the domain and range of this function. So if you put x equal to minus 4, you will get 16 here. All will be positive number. If in place of -3 it will be 9, then 4, then 1, this will give 0, this will give 1, this is 4, 3, 4, 16. So students, what we have seen, that domain is actually real number. Any number it can be from the real number set, but range always will be the square number of that real number. So now you will see that what will be the graph of this type of function. So first we will draw the x and y axis. Okay, after drawing x and y axis, we will make we will put these values whatever we got here in the given table. So those values if you put, you will get this type of bell shaped curve, and it is called, it has one specific name, that is parabola. So students, we have learned about polynomial function, but when we define polynomial function, we have mentioned n will be non-negative positive integer. For non-negative positive integer, this equation is not a polynomial function, because 2 by 3 is not negative integer. It's not a non-negative integer, it's a rational number. So students, now we will see another example that is telling us that draw the graph of function f from real number to real number, and which is defined by f of x equal to x cube. Generally we know this one as a cubic function. When any polynomial have highest degree 3, then it's called cubic function. So now if you draw again one table, and at the table if you put the values of x and y, so you will get, for 1 you will get 1, for 0 you will get 0, and -1 -1, f of 2 8, for -2 it will be -8. This way it will continue, and after putting these all values in the Cartesian coordinate system, first drawing x and y, marking 1 2 3 1 2 3 this, so we get one this type of curve which has shown in this given figure. So this figure showing f of x equal to x cube type of function, and you will remember this type of function always have a curve in the Cartesian coordinate plane. So hope you understood today's lecture. So if you uh, have any problem, you will contact or message me. Thank you. Have a nice day.